Good day, students. You are welcome to another lecture by Nelstar Tutorial. My name is Justin Water. I will be handling you on the following courses, a total of 15 courses. So, today let's look at number 2. Number 2, that is Physics O level. Physics. What I'm going to teach you now is not only beneficial to physics students, it is also beneficial to chemistry students. Now, during our first lecture on both chemistry and physics, we made mention and emphasized that chemistry is interested in what? The make-up of what? Matter. This is what chemistry is interested in. What is it that make up matter? What is it make up? Like the constituents of matter. Why physics is interested in what? The energy contained inside matter. Makeup of matter, chemistry. Physics interested in the energy contained inside matter. We went extra mile to explain what energy is. We made also extra mile to explain what matter is. Remember, as I earlier said, matter is anything that has weight and occupies space. So if something has weight, automatically it has mass. Occupying space means that it can take up a particular position. It can take up a particular position. If you keep it inside on a table, let me see, this is a table. You keep a book here. This book will occupy this space. Nothing else will be occupied. This space it is, it's nothing else can be here. Unless you put another thing on top of it. It has taken up position. We also explain matter also from the angle of inertia. Anything that has mass or weight. Anything, when you try to tell it to move, is reluctant to move. Or if it's already moving, to tell it to stop, it finds it difficult to stop. That is inertia. Now, all these things we are talking about physics, about physics or chemistry, revolve around this thing called matter. Whether chemistry, matter. Whether physics, matter. And I told you that that's the language of science. Anything in the universe, let me say everything on earth is matter. Anything, whether you can see it or not, is matter. Except energy. The universe is made up of energy and matter. Now, what is this matter we're talking about? Experts have gone further to tell us that matter is made up of atom. Further breakup of atom gives us what they call particles, atomic particles. Called atomic particles, and there are 3: proton, neutron, and electron. Please, my students, at this point in time, you have to pay very attention, because you have to form a mind of what this atom is all about, and make up a mind on what these particles are all about. The technology that is used to discover these particles, proton, electron, and neutron, is beyond the scope of this what I'm doing now. But towards the end of this, by the time I was doing this lesson for a very long time, when we enter into atomic and nuclear physics, then I will now start to explain to you the machines that make scientists to come to the conclusion that anything matter is made up of what? Atom. You break up the atom again, you get particles, proton, electron, and neutron. Now, what is an atom? Anything around you whether visible or invisible, whether in solid form, liquid form, gaseous. Please, when I mention something like solid, your mind should go to e.g. stone. Make up something in my mind about what shit is I mean. What I'm holding on my hand is just a solid. When we talk about liquid, e.g., your mind should go to things like water, kerosene. When I mention things like gases, your mind should go to things like air or breeze. Then what is this thing called atom? That's where the question is. Because this is what normally gives students a lot of problem. Anything, be in the form of solid, be in the form of liquid, or be in the form of gas, is made up of atom. All the chemical elements I mentioned in the chemical, I showed the periodic table, starting from hydrogen. This is 1, 2, 3, up to organesium, organesium, 118. All of them in between here, hydrogen, all of them one by one. They are all is not all. Every one of them has its own atom. Whether you see it or you don't see it, whether it's visible or invisible, it has atom. This thing I'm holding now is paper. Paper has its own atom. I will explain a bit atom. Because when we say atom go hand in hand with molecules. This paper I'm holding now, I can tear it into two. Drop one part. Tear the one I have here into two again. Drop one part. Tear this one again. Drop one part. Continue tearing this one I'm holding. One part. Continue tearing this one part. Continue tearing. A time will come when I can no longer tear such. It becomes very, very impossible. I may even be tearing my hand. It may not possible. So imagine that smallest part, which you can no longer tear, which you can no longer even see. That is what? Atom. So atom is defined as the smallest particle of an element. The initial definition of atom was told as the smallest indivisible particle of an element. That was the old definition. But atoms are not divisible. Further manipulation of atom leads to what we call atomic particles made up of proton, neutron, and electron. And scientists have viewed this thing under a powerful microscope called field ion microscope. And based on other experiments they carry out, they find out that this atom is like this. It has a nucleus. At the center of this nucleus are two subatomic particles, proton, neutron. At the surface like this are what? The electrons. So this is the idea we are going to use for now to be studying. When we hear about matter, your mind should go to what? Anything matter has weight. Anything matter has weight. Anything matter, whether solid, liquid, or gas, it has weight. Once it has weight, automatically it has mass. Our next lecture will be about this weight and mass, the difference. If it has weight, it has mass. And if it has weight, it has mass, surely it is made up of what? Tiny particles called what? Atoms. This thing I'm holding now, when you accumulate millions of atoms of this thing and bring them together, that is what you see this thing holding. Now, these atoms, further breaking up, give us what we call atomic particles. Atomic particles are what? They are proton, neutron, and electron. What are we doing? We are still digging into this topic, this topic called matter, because the definition of chemistry revolves around matter. The definition of physics revolves also around what? Matter. Physics is energy inside matter. So let us get more knowledge about this thing called matter before we can now move on. So anything that's called matter has weight. It has mass. It is made up of millions of atoms. And in each of those atoms, if broken into further pieces, gives us the proton, neutron, and electron, which is the subatomic particles. Now, since we are still dealing on this matter, we want to get more and more knowledge about this matter before we enter into chemistry and physics program. What we now ask ourselves is this thing. Under what condition does matter exist? This of matter. Under what condition or form does matter exist? Is it a solid form? Solid form? Is it in liquid form? Is it in gaseous form? Please, as I'm teaching you this thing, please try to imagine something physical for you to enhance your understanding. If I take solid is a solid form, example, stone. This paper I'm holding here is solid. Metals. No, let me use thing around here. Yeah. Iron. Then when I say in liquid form, your mind should go to things like what? Water, e.g. water. Kerosene. Then when I go to say something like gaseous form, go to something like breeze or air. We're coming to that. There are different types of gases that exist. Now, under what condition does matter exist? Matter exists in any of these three forms. Depending on the purpose man wants each one to do, we determine the one may have need of. Matter, whether visible or invisible, it has weight. All the 92 occurring elements, all the 118 occurring natural elements, they are all matter. Some of them exist in solid form. Some exist in liquid form, while others exist in what? Gaseous form. Now, stone is a solid form. Iron is a solid form. Water is in liquid form. Air or breeze is in gaseous form. Now, let's all look at further explanation. Now, let us look at what the other things, let us summarize all the other things we have known about matter. 1. Matter has weight. 2. Matter occupies space. 3. Matter has energy. Four, matter is built up from millions of atoms. The atoms is the atoms themselves. The atoms are built up from millions of particles. Those particles are called proton, electron, neutron, and what? Electron. These are some of what I've said about matter. Now, let us now look at the special properties of matter. What I think we have to tell you about here is that matter is compressible. So when we look at the special properties of matter, that's when we explain more about this being compressible. You know, it's compressible, spring. You can compress a spring like this, and this is go like this. But in the case of matter, matter can be compressed, but it depends on which type of matter are you compressing. The gaseous form is easily compressible, followed by the liquid form, and hardly by the what? Solid form. So now let us look at the special properties of matter, one by one. The special properties of matter, which are going to look one by one. The first one is the solid form of matter. One, solid form of matter. Imagine this thing I'm holding is solid. Imagine that thing around it is solid. This paper I'm holding is also what? Solid. Now, what are the properties of solid state of matter? A, the particles are tightly held together. The particles or atoms, use the word atoms, atoms are tightly held together. B, what do you mean by the particles are tightly held together? They make up the millions of atoms that make up the solid. They are tightly held together. They hold themselves so tight that any attempt you are making to remove it from its partner, it will surely resist it. If you try to disturb it, it will hardly move. Unless you apply extra pressure. And some of those things they apply, they be hitting. When you hit it, it will now get let loose. Now you can separate one atom of solid from its other, from its neighbors. That's that. Solid have a specific shape. Solid has a specific shape. C, solids have a specific volume. D, that's that for now. Solid has a specific shape. Solid has a specific. That's very, very clear. It explains itself. The shape of this is solid. The shape of this thing is specific. This is solid. The shape is also specific. Now, let us look at the second form of matter. Another second form of matter called the liquid form of water, of matter. Matter. Your mind should go to example of liquid. Example, commonest example is what? Water. Now, water has no specific shape. Water, liquid has no specific shape. Liquid has a definite volume. The particles or atoms, the particles or molecules that make up the particles of liquid are loosely packed. The particles of liquid are loosely packed. The particles of liquid are loosely packed. I said it has no definite shape. If a liquid is poured into a cylinder, if you pour a liquid inside a cylinder, you know what will happen to the liquid? It will take up the shape of the cylinder. If you pour it into a cylinder like this, the liquid will take up the shape of the cylinder. If you pour a liquid inside a cuboid, it will take up the shape of the cuboid. So it has no specific shape. Now let us look at gases. 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 Third. Gaseous state of matter. The particles are too loose. The particles of gases, the particles took atoms of gases are too loose. 2. Gases are easily compressible. Gases are easily compressible. Gases are easily compressible. Gases have no fixed volume. They have no fixed volume. Number 4. They have no specific shape. Now, let me explain. The particles of gases are too loose. The particles are not holding one another close, so tight, unlike the way we have it in solid and the way we have it in liquid. That's why at the slightest disturbance of the molecule of the atoms of gases, what do I mean by disturbance? If you just apply a little heat, the gases, the molecule that make up the gases become too loose. They become violent. They spread out easily. If you press perfume on one corner of the room, before you know it, the particles of the perfume have spread to the whole part of the room. This is how you show that the particles are too loose. Gases are easily compressible. A gas that enters into a container like this, as big as this, can be forced to enter into a container as small as this, the same gas. But you can't try it on a solid. A solid that you force to enter into something like this. Here, you can't force it to enter something like this. Liquid can also, you cannot do that. You can do it to a liquid to an extent. But that of gases, when that's of being compressible, being forced together, gases are very, very obedient. Now, with all these things we have mentioned about solid, liquid, and gaseous, that determines whatever you want to do on earth, whatever you want to construct, whatever you want to do, what you want and what you want to achieve. We determine, all these parameters listed will guide you to determine whether you are going to use matter in solid form, matter in liquid form, or matter in gaseous form. The commonest example about matter being used is the internal combustion engine. Inside the engine of a car, or a generator, or an aeroplane, or any internal combustion engine, you have something like this. This one is called a piston. Piston. Why this container is called a cylinder? Now connections are made from here. The work of this piston is to move up and down inside the cylinder. Petrol, liquefied fuel in the form of gas, not solid this time, not liquid this time. The petrol that enters inside the engine is in form of gas. When the gas ends here, and the spark plug, which normally see here, the spark plug will ignite this liquefied petrol or fuel, and it starts burning. As it burns, it releases heat. And it's not the generated heat, it releases a large amount of pressure. What will happen to this gas? Because this is gas, it has been heated. The particles are is thrown loose. As it's heated now, the gases become too violent. As they have become too violent, what happened? They will now push this piston up. This movement of piston, this now is connected to a crankshaft. Another piston here. This is now connected to a crankshaft. Before this crankshaft will now start rotating. This rotation now is transmitted to the tire of the motor car, and you now see what? Motion. So this is an important area where you see in the construction of internal combustion engines, be it motorcycle, aeroplane, motor itself, gasoline generator, and whatnot. Gases are easily, because of the loose nature of gas and the compressible nature of gas. That's why the liquid fuel, like petrol, is first of all converted into gas. And now it is ignited. This is how internal combustion engine work. Now, we are still on matter. And we are trying to, because matter is at the heart of chemistry. Matter is at the heart of physics. So this matter needs to be properly dealt with before we now enter into physics proper or into chemistry proper. Now, scientists have carried out some other research about matter. And these researches that are carried out, based on majority of which are experimental, carried out in the laboratory experiments, they have estimated one, what is the size of an atom or molecule. Please, when I mention atom, oxygen molecule, they are more or less the same thing. See the difference. Water is made up of what? Hydrogen and what? Oxygen. The tiniest particle of oxygen, this is an element, tiniest particle of oxygen, tiniest particle of hydrogen is atom. Atom. When hydrogen and oxygen combine together, they are no more, it's no more hydrogen, it's no more oxygen. When they combine together now they become what? Water. H2O. So the tiniest particle of water is called what? Molecule. The tiniest particle of an element is atom. While the tiniest particle of what? Of a compound is what? Molecule. So these are elements. Elements. What is what? Compound. Two or more atoms chemically joined together is called what? Compound. And the smallest particle of it is called what? Molecule. Let us look at another distinct. Sodium chloride, common salt used in the home, is made up of two elements, sodium and what? Chlorine. The tiniest of sodium is what? Atom. Tiniest of chlorine is what? Atom. These two together are called elements. Why this one is called what? Compound. The tiniest particle of this compound is called what? Molecule. So let's continue. Now, scientists have carried research and came out with and studied the size of a molecule or size of an atom. We're not going to do that one here because that one is a very long distance. But I want to compile a compilation of researches carried by scientists still on this thing called matter, matter, before they came to the conclusion. They also have carried out research and find out this thing, what we call adhesive, and cohesive forces of matter. These scientists have gone further. They have studied what we call surface tension. Surface tension. These scientists did not stop there. They have also studied what we call capillarity. Capillarity. They have also carried out research studying what we call osmosis. They did not stop there. Only they begin to understand this thing called matter more and more. They have also carried out research and studies about diffusion. They have carried out research about studies about the Brownian motion. Brownian motion. And finally, after studying all this, they also carried out research and studies about the crystal structure of substances. Crystal structure. Of matter. They have carried out research about 9 about amorphous substances. Amorphous substances. With all these studies the scientists have carried out and studied, they finally came up with this theory called the molecular theory of matter. Molecular theory of matter. Came up with this theory called the molecular theory. Now listen. You know what led us into this matter? Chemistry revolves around matter. Physics revolves around energy and matter. So we need to give a deeper blow to this topic called matter before we can now move on. Now, after all these researches and studies carried out by scientists, they came up with the molecular theory of matter. And the molecular theory of matter is saying that all matter, be it solid, liquid, or gaseous, is made up of tiny particles. These tiny particles can be called atoms, molecules, or ions. These particles cannot be seen even with the microscope, but we have evidence that they exist based on what is studied in diffusion, osmosis, crystal shapes, Brownian motion, and so on. This molecular theory states that all matter consists of molecules, which are the smallest particle of the substance that can exist. Very important. This molecular theory states that all matter consists of molecules, which are the smallest particle of the substance that can exist. Let us look at them properly under each of their three classes of matter. A. Solid. Solid state. Many things around us which we see and touch are solid. It also includes things in powdered form. You don't need to be told how you will feel when you hit your head, when you hit your leg on a solid material. Molecules in solids are closely packed together in definite shapes. The distance between one molecule and the other is too small or negligible. The intermolecular attraction is large. When heat is applied to a solid, the bond holding the molecules together is broken. The molecules now start moving about randomly and uncontrollably. As the heat continues, the molecules will now distance themselves from one another. That is the distance between one molecule and the other now becomes large. This makes the solid now to become what? Liquid. That is that. B. Liquid. The molecules in the liquid are widely spaced apart than the solids. The molecules are free to move about within the confined container. The molecules are not confined to any fixed position. The molecules are very loose compared with that of solid. As more and more heat is applied to the solid, the bond holding the solid together, they lose each other. As more and more heat is continued, the solid now changes to what? And becomes what? Liquid. Finally, gaseous. Gaseous or gases. In terms of being loose, this is the most loose among all the states of matter. When heat is applied to this, the bond holding them together will lose. As this continues, it becomes liquid. As more and more heat is continues, the bond holding the liquids together, they leave each other, and then becomes what? Gaseous. Hence, gaseous is the commonest when it comes to being loose. The commonest example we use to explain this molecular theory of matter, the molecules of particles that make up the gaseous form are very, very loose. And that's why at the application of heat, they become uncontrollable, they become violent. Inside the container where you keep the gases, inside the container, this is how they will hit the walls of the container. Just uncontrollably. That is why gases are used. The fuel you put in your motor car is converted to gas and set on fire. As the gas is burning, that's why now they become violent and they be in a position to push the piston up and down. Push the piston up and down. As you push the piston will push the crankshaft, and then you have retraction motion. which is now being translated to the waves. The commonest example we use to justify, to explain this is what? Let's take an example of a solid. This is solid. Solid. Let's take an example. For example, ice block. Liquid. Water. Gaseous. Gas. Gaseous. Let's common example. Once heat is applied to this solid, this ice block, after some time, what happens? The ice block, the bond holding them together, all the atoms of solid holding themselves together, will relax. When the heat becomes much, the particles holding it, they totally leave each other. Each one will be on its own. Then what turns is liquid. You continue heating this liquid, heating this liquid. Once it gets to 100 degrees centigrade, the particles or molecules holding the liquid together will start leaving each other. Evaporation begins. They start leaving each other, leaving the surface of the water. And when the heat continues, before you know it, the liquid will vanish. You are left with what? Gaseous form. And the gaseous form this is called water vapor. This is water. That's the liquid. But this is ice block. This is the commonest example we normally use to explain solid, liquid, and gaseous from one stage to another. This is application of heat that resulted to this. If you can bring the vapor together, withdraw the heat from those vapor, if you come back, the thing will come back to liquid. Withdraw the heat from that liquid, withdrawal of heat from refrigerator, this will come back to ice block. So now, we have given enough explanation about this matter. You recall when we defined physics, when we defined physics and chemistry, everything is revolving around this thing called matter. And we have now gone further to find out what is inside matter. Further analysis inside matter. We think that empty matter has weight. If it has weight, it has mass. It has mass. It's made up of tiny particles called atoms. Further breakup of those tiny particles give atomic particles called electron, proton, and neutron. So whether something is solid form or liquid form or gaseous form, you should form in your mind how those things look, the particle makeup of those things, how they look like. Bear it in mind, the particles that make up solids are packed together, while those of gaseous are what? Very, very loose. That of water, liquid, is in between. And the application of heat, slightest heat, this one will go mad, become violent. This one will take some time. The particles of this one, if you apply heat, they will still find it very reluctant to leave each other. The atoms will hold each other very, very tight. They still reluctant to. But when the heat becomes too much, they have no option. They will lose ground and that become liquid. From further application of liquid, more application of heat, this thing becomes gases. That marks the end of today's lecture. By our next lecture, the next thing we're going to look at is what? The tools required to study physics, which is more or less related to the tools required to study chemistry, because many students find physics difficult and chemistry. It's not the theory that makes them to fail, it's the calculation aspect. So all the theory, all the calculation, most of the calculation involved in the study of chemistry, instead of the study of physics, we are going to take them one after the other. After that, now we enter into physics proper and into chemistry proper. You can subscribe to my channel. I am Nelstar Tutorial. This is my number here. I'm going to handle you on the following courses. You can see the following courses here: general maths, physics, chemistry, basic programming, additional or further mathematics, computer science, statistics, calculus 1. Under maths level, I teach you further mathematics, pure mathematics, teach you statistics 2, teach you mechanics, teach you calculus 3. Then I teach you calculus 3 also, teach you differential equations with boundary value problems. And I will also teach you advanced differential equations and special functions. Till some other time. Thank you very much.